10.5 notes, polar form of complex numbers, page 5. You guys, we are going to look for the nth roots of a complex number, and this is really one of the most fascinating things about complex numbers in polar form or trig form, because there is a nice geometric connection to what we've got going on here with the roots. So here is the formula for finding the nth root. Again, we're going to define our complex number z as r times the quantity cosine theta plus I sine theta. If we want the nth root, it falls right in line with what we did when we were finding the power. We're going to take the nth root of the modulus, and then our angle is going to be divided by n, but we need multiple rotations around the unit circle. So we are going to add 2 pi k and divide by n until we get the number of roots we need. And hopefully I can help that make a little more sense at this point in a minute. Okay, so example 8a. We want the 3 cube roots of z equals negative 2 plus 2, 1. Notice it is not in polar form. It's not in the form I want. So I need to start by rewriting this in polar form. So r is going to be the square root of negative 2 squared plus 2 squared, which is the square root of 4 plus 4, square root of 8, which for now, I'm going to leave it that way. Keep in mind, this is 8 to the 1/2. 8 is also 2 to the 3rd. So there are multiple ways we can write this, and I'm going to pick the one that's most useful as we move forward. Also need to find theta. And that's going to be the inverse tangent of 2 over negative 2. So the inverse tangent of negative 1, which gives me an angle of 3 pi over 4. I know that it's in the second quadrant because my A is negative, my B is positive. So that's all good. Okay. And if we want, we can remember that's 135 degrees. Sometimes it's nice to think of these in terms of degrees. Okay, so now here is my complex number. What do we have? Square root of 8. I'm just going to leave it like that for now. Cosine 135 plus I sine 135 degrees. And now we want to find the cube roots. And so taking a look at our equation up top here, I am going to stick to this notation so that I can keep track of everything. So z sub 0, okay, my first cube root is going to be let's do this. I'm going to write this as 2 to the 3/2 to the 1/3. The cube root of square root of 8, or the cube root of 2 to the 3/2. And then I've got the cosine of 135 plus, notice how it says k starts at 0. So I'm going to add 360 times 0, and I'm just writing that in there so we keep track of everything, divided by 3, plus I sine, same thing. 135, I'm not going to worry about the 360 times 0. Okay. And so I get 2 to the 3/2 to the 1/3 is 2 to the 1/2, so square root of 2, times cosine 135 divided by 3 is 45, plus I sine 45. These angles are always going to be the same. There's my first root. Here's my second root. I'm just going to go ahead and shorthand this. I know that 2 to the 3/2 to the 1/3 is going to be square root of 2. And then I've got cosine of 135 plus 360 times 1. My k's are increasing, all divided by 3 plus I sine, let's see, 135 plus 360 is 495. Just try to combine the work here a little bit. So I get square root of 2. Cosine of 495 divided by 3 is 165. Plus I sine 165. And since we're looking for cube roots, we need 3 of them. And this is where this n minus 1 comes into play. If I start at k equals 0, I get 3 cube roots by using k equals 0, k equals 1, and k equals 2. And here I got cosine 135 plus 360 times 2 all over 3. So that is I sine 720 plus 135 is 855. I get square root of 2, cosine of 285 plus I sine 285. So something I do want you to notice here, difference between these angles, 45 plus 120 is our 165. 165 plus 120 gives me our 285. 285 plus 120 is 405. Which is the same as a 45-degree angle. Those are coterminal. Why 120? Well, 360 divided by 3 is 120. So when we're looking for the cube roots, notice that our 3 cube roots are spread apart equally around the units, or sorry, around our circle, okay? So here, I'm gonna 1, 2, give me a little more space here. So square root of 2 cosine of, square root of 2 at a 45-degree angle. So 45 is our pi over 4. Square root of 2 is roughly right here. 165, that's halfway between 150 and 180, so that's our 11 pi over 12. So 1 roughly here. And then 285, that's 270 plus another 15. So I'm looking at right here. Notice these 3. Each have 120 degrees between them. Okay, so they are spread out evenly, or they divide that circle into 3 equal parts, angle-wise. So B, find the 5th roots of Z equals 32 cosine 5 pi over 6 plus I sine 5 pi over 6. So I've already got this written in polar form. That helps. And so we're going to do what we did before. So Z sub 0. The 5th root of 32 times the cosine. We're going to go ahead and leave this one in radians. And what I get is 5 pi over 6. This one's going to be plus 2k times 0, all divided by 5, which is I sine 5 pi over 30. I get 2. 5 pi over 30 we can reduce to pi over 6. So cosine pi over 6 plus I sine pi over 6. 1, 2. My second root, stick that 2 out front. I have cosine 5 pi over 6 plus 2 pi times 1 all over 5. That gives me I sine. 5 pi over 6 plus 12 pi over 6 gives me 17 pi over 6. We're going to divide that by 5. So I get 2 cosine 17 pi over 30 plus I sine 17 pi over 30. Two cosine, we are just going to do the same thing. 5 pi over 6. This time my 2 pi gets multiplied by 2. So 2 pi times 2, 4 pi. When we convert that to a fraction with 6 in the denominator, we have 24 pi over 6, which we're going to add to 5. So I get 29 pi over 6, all divided by 5. I get 2 cosine I sine 29 pi over 30. Shorthand here means exactly the same as what we've written above. Cosine, I've got 5 pi over 6 plus 2 pi times 3. So I have 6 pi that I need to convert to a fraction with 6 in the denominator. So 36 pi over 6 plus 5 pi gives me a 41 pi over 6, again divided by 5. And I get 2 cis 41 pi over 30. See, 1, 2, oh, this is good. I'm just learning how to count. This is 2, this is 3, this is 4. 2 cosine 5 pi over 6 plus 2 pi times 4, my subscript on the z, all divided by 5, gives me I sine 53 pi over 6 divided by 5. I get 2 cis 53 pi over 30. Okay, so not a ton of room there, but over here let's take a look at actually what these angles are. Pi over 6 we know is 30 degrees. 17 pi over 30 is 102 degrees. 29 pi over 30 is 174 degrees. 41 pi over 30 is 246 degrees. And 53 pi over 30 is 318 degrees. All of these are 72 degrees apart. Because 360 divided by 5 is 72. I'm going to use those to help me graph this because I don't have my circle divided into pi over 30s. So I've got my pi over 6, that one's easy. 17 pi over 30, well 15 pi over 30 would be pi over 2. So I know I'm a little bit past pi over 2. Not quite to, oops, sorry, down one. Not quite to 7 pi over 12, which is 105 degrees. My next one, 174 degrees, we know that needs to just be shy of 180. 246. So 4 pi over 3 is 240, so we're going a little past 4 pi over 3. And then 318, so we know 5 pi over 3 is 300. 11 pi over 6 is 330. So a little more than halfway between those two. There are my fifth roots, evenly spaced around my pole. There are the 5/5 roots of z equals 32 times the cosine of 5 pi over 6 plus I sine pi over 6. So C, last one, and we kind of like this one because this one is easy for us to double check. We want the 4/4 roots of z equals 1. So 1, 2, 3, I'm going to make this 1. If z equals 1, think about what that means. Z equals 1 times cosine of 0 plus I sine 0. Degrees, radians, doesn't really matter. Okay, cosine at 0 is 1, sine at 0 is 0. 1 times 1 gives me 1, z equals 1. Okay. So the first 4 roots, I want the 4th root of 1. Well, that's kind of nice. I like that. And then I have the cosine of 0 plus, we'll go radians, 2 pi over 0 divided by 4. That's still 0. Oops. Running out of room, so we're going to shorthand. Our second 4th root of 1 is 1. I've got cosine 0 plus 2 pi times 1, all divided by 4. So 2 pi over 4 is going to give me a pi over 2. And we are just going to keep going. 0 plus 2 pi times 2 divided by 4 gives me I sine 4 pi over 4. And we can kind of see the pattern here. I mean, if I look at these, I've got here, 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 and we know we're dividing this into 4 equal parts, so my last 4th root should be right here. I get cosine 0 plus 2 pi times 3 over 4 plus I sine 6 pi over 4, 1 cis, 3 pi over 2. And here are my 4th roots, evenly dividing my circle into 4 equal parts. And that is it for the notes.